Hi everyone. For this lesson today you're going to need your math notebook and workbook, a pencil with an eraser, a math board, a dry erase marker, and something to erase the dry erase marker with, like a tissue. The learning target for this lesson is that you will be able to use the math board to discuss basic fraction ideas. Here's an image that shows something very similar to your math board. There's a few things that you need to know about the math board. First, the top bar shows one whole. The other bars underneath that show the same size whole divided into different numbers of equal parts. All of the bars underneath the whole are labeled halves, thirds, fourths, and so on. The bar labeled halves is broken into 2 equal parts. The bar labeled thirds is broken into 3 equal parts, and so on. Here, this bar is labeled fourths, 1/4, and there are 1, 2, 3, 4 equal parts. The number of parts increases, meaning gets bigger, with each bar, while the size of the parts decreases. The whole is the same for all of the bars. So as you look from the whole down, the number of parts starts off, let's say with halves, there are 2 parts, and then that number increases to 3 parts, 4 parts, and so on. So the number of parts gets bigger, but the actual size of these pieces gets smaller. The size has to get smaller because you're breaking that same size whole into more and more pieces. Let's take a look at unit fractions. What fraction does each part of the halves bar represent? Well, since there's 2 pieces, we know that the denominator has to be 2. Each of the pieces is one of 2 equal size pieces. When you label the fraction bars, the first part of every fraction bar will always have a numerator of 1. We call these unit fractions. Each individual part of the fraction bars are called unit fractions. Now go to your math board and label the first part of the rest of the bars with the correct unit fraction. Pause the video until you're done and then come back to the video. Think about it. What do all of the fractions you wrote have in common? And what do we call fractions like this? Since the first part of all of the fraction bars are the unit fraction, we will call them unit fractions. What they have in common is they all have a numerator of 1. So the first part of the halves bar was 1/2. The first part of the thirds bar was 1/3. The first part of the fourths bar was 1/4. And this pattern continues all the way down the fraction board, the math board. Here's an image that shows the fraction poster that you see hanging in the classroom. The first unit fraction on each bar is darker so that it's easier to see. Take a minute and look for patterns on the poster. The denominator, D for downstairs, is the number of equal parts in the bar. What happens to the size of the parts as the denominator increases? Why? Think back, we talked about this just a couple of slides ago. As the denominator increases, the size of the parts actually gets smaller, and the reason why that happens is because you're taking the same size whole and you're breaking it into more and more parts. We can use unit fractions to build a whole. How do you think we can build a whole by adding unit fractions? Take a second right now and try to model this on your math board with 2 different fraction bars. Then try to think of a generalization, which is just a general rule for adding unit fractions to get a whole. Here are 2 examples. For the thirds bar, each of the pieces is 1/3. There are 3 of them. If you add all of the thirds, you'll end up with 3 total thirds. 3/3 is equal to 1 whole. Same thing with fourths. Each of the pieces is 1 of 4 equal parts. If we add 4 fourths, we get a total of 4 fourths, which is the same as 1 whole. So for any of the fraction bars, we can build a whole by adding all of its unit fractions. In general, this is the generalization, we must add d unit fractions, 1 over d, to get a whole. D just stands for any number. It's called a variable. So let's say, for example, that we were going to build a whole from tenths. That means that d is equal to 10. 1 over 10 would mean that we would have to add 1/10 10 times in order to equal 1 whole. Any fraction with the same numerator and denominator is equal to 1 whole because it represents all of the equal parts in the whole. 10 tenths then is equal to 1 whole. 5/5 is equal to a whole. 7/7 is equal to a whole. 1,000,000 millionths is equal to a whole, and on until infinity. You can also use unit fractions to build other fractions. Any fraction that is not a unit fraction can be built by adding unit fractions. Here's an example. If we wanted to build 3/5, we would add 1/5 plus 1/5 plus 1/5. That gives us 3 total fifths. Here's how the equation looks. 3/5 is equal to or the same as 1/5 plus 1/5 plus 1/5. Since we have repeated addition of 1/5 plus 1/5 plus 1/5, we could also say 3/5 is equal to 3 times 1/5. The denominator tells the number of unit fractions in the whole. 5/5 is made up of 5 unit fractions. 5/5 or 5 1/5. The numerator tells the number of unit fractions in the fraction. 3/5 is made up of 3 unit fractions. Here's how we're going to use that information about building fractions and unit fractions. Mr. Ellis is building a sidewalk. Yesterday he built 2/6 of the sidewalk. Today he built 3/6 of the sidewalk. What fraction of the sidewalk has he built? Here's some questions. How can we figure out what operation to use? How do we perform this operation? Use the math board to model this problem. Well, since we know that he has already built 2/6 and today he built 3/6, we've got 2 parts and we're trying to figure out the whole. When we are trying to figure a whole from 2 separate parts, we are going to use addition. Here's how to model that on your math board. Since the parts that he built are sixths, the first day was 2/6, we can circle 2/6. The next day was 3/6, so we can circle 3/6. To find the total amount, we can combine those and add all of the number of sixths total for a total of 5/6. Here's another example. We had 5/8 of a pizza. Then we ate 3/8 of it. How much pizza is left? In this example, we started out with the entire amount of 5/8. Since we were eating some of it, we're taking away. Using that information tells us to subtract. We can model this on the math board as well. We started out with 5/8 of a pizza. So if you circle 5/8, and then you can cross out the part that we ate since we're taking that away. Crossing out 3/8 leaves us with 2/8 left of the pizza. So think back. What are unit fractions? How are they used to build other fractions? Draw a model of this. Unit fractions are any fractions with a numerator of 1 over a denominator. An example is 1/10, another example is 1/100th, and so on. How do we use unit fractions to build other fractions? We simply add unit fractions to build other fractions. So let's say that we have the fraction 3/8. We would use unit fractions with the same denominator to build 3/8. 1/8 plus 1/8 plus 1/8 is equal to 3/8. You can use your math board to model this to show 3/8. For independent practice today, you are going to do homework page 1 for lesson 1-1. This will be due tomorrow.